Hello everyone. In this problem, we'll work with permutation and probability using a word kangaroo and a 8-sided die. First, we'll determine the number of different arrangement of the letter in the word kangaroo with conditions that the two A's must stay together while the two O's must not be together. So, we'll solve this problem in 4 steps. First of all, we are given two conditions. So our two conditions are that two A's must be together and two O's must not be together. So now we'll solve this problem in 4 steps. Now our first step will be that we will treat two A's as a single block. So the distinct items to arrange will be K, and we will treat two A's as a single unit, and then N, G, R, O and O. So total items will be 6 distinct letters plus 1 block. So there will be in total 7 items. Now our step 2 is we have to arrange all items except the O's. So basically, to ensure that two O's are not together, we first arrange the 5 items, that is K, 2 times A, then N, G, R. And now number of ways to arrange these 5 items are 5 factorial, which is nothing but 120. Okay, now our step 3 will be we have to place these two O's in the gaps. Place O's in the gaps. Now which gaps I am talking about? We'll place the 5 items from step 2 and identify the gap. Basically there will be gap, then item, then gap, then item. Like this, there will be gaps and then items. So like this, there will be gap, then item, then gap, then item, then gap, then item, and so on. So there are in total possible 6 gaps for two O's. There are 6 gaps for two O's. Now, number of ways to choose 2 gaps out of 6 will be 6C2, which will be nothing but 6 into 5 by 2, which is 15. Next is our step 4, in which I'll combine the total arrangements. I'll find the total arrangements. So total arrangements are ways to arrange other letters, that is 120, and ways to arrange O's, that is 15, that we calculated in step 2 and 3. So now if I calculate this will be 1800, which will be our final answer. So if we quickly revise it, first of all, I treated both the A's as 1 unit, and then I got total items as 7, and then if I separate the O's, there would be total 5 items, and to arrange 5 items we have 5 factorial ways to arrange the 5 items. Then we have to place O in the gaps so that no two O are together. So there are total 6 gaps, and to choose 2 gaps out of 6 we have 6C2 ways. So it will be 6 into 5 over 2, that is 15 ways. Now, so total possible arrangements will be number of ways to arrange that 5 letters, that is 120, and then number of ways to place O's, that will be 15. Now if I multiply both of them, it will be 1800. Now in B part, we have a fair 8-sided dice has faces labeled as KANGAROO. Basically kangaroo, letters of kangaroo. Now the dice is rolled repeatedly. Now we have to find the probability that fewer than 6 rolls of the dice are required to obtain A. To solve this question, first of all, I will find the probability of rolling A, which is denoted by P, will be equals to 2 over 8, because we have 2 A's and in total there are 8 letters, which is 1 over 4. Now Q denotes probability of not A. not rolling a. So this is 1 minus 1 by 4, which is 3 by 4. So now fewer than 6 rolls means that we get a on 1, 2, 3 or 5. Or this is equivalent to saying that we don't fail 5 times in a row. So probability of roll less than 5 is equivalent to 1 minus probability of no A in the first 5 rolls, which is equals to 1 minus 3 by 4 power 5. If I solve this, it will be 1 minus 243 over 1024. Now if I solve this further, I'll get 781 over 1024. This will be our final answer. Now C part is we have to find the probability that second A is obtained on 6th roll of the dice. Now for the second A to occur exactly on 6th roll, two things must be true. First is exactly one A occur in first 5 roll and the 6th roll must be an A. Now for the first case, to find the probability of 1A in first 5 rolls, we'll use binomial theorem. So the binomial formula is NCK P power K Q power N minus K. So now I want probability of 1A in 5 rolls. So it will be 5C1, 1 by 4 power 1 and 3 by 4 power 4. So now if I solve this, it will be 5 into 1 by 4 into 81 over 256, which will be further equals to 405 over 1024. Now the next case is that 6th roll must be an A. So probability of 6th roll is A is 1 over 4. Now probability of total basically of both the cases will be 405 upon 1024, 4 into 1 by 4, which is nothing but 405 upon 4096. If we approximately calculate it, it will be 0.0989. This will be our final answer.